Okay, now, anong mangyayari sa glycerol na na-produce after digestion ng lipids? Okay, so remember that triacylglycerol has two parts. The triacylglycerol has glycerol and the fatty acid, three fatty acids. So, anong mangyayari dito? So, one molecule of glycerol, which has been produced after triacylglycerol has been completely hydrolyzed, they are now going to enter the bloodstream, and glycerol travels to the liver or kidney, wherein it is converted into a two-step process producing the dihydroxyacetone phosphate. Ito. Dihydroxyacetone phosphate, kung medyo it rings a bell sa inyong memory, dihydroxyacetone phosphate is one of the subproducts during the 10-step process of glycolysis. So, ito yung isa sa mga product, particularly dun sa cleavaging ng ating fructose. Nung na-cleavage siya, nung na-break siya, I think that is stage 4, na-produce ang isang dihydroxyacetone phosphate. And yung other one is glyceraldehyde, I think. Okay? So, what are these two-step process? So, glycerol having this 3 carbon atom and 3 hydroxyl group. With this conversion, ang site of reaction natin is the hydroxyl dito sa terminal carbon atom. So, first step is we use the ATP to supply the phosphate group. So, after giving one phosphate from the ATP, that ATP will then become ADP. With the presence of glycerol kinase, na transfer ang ating phosphate from ATP to this site of glycerol. Hence, it will then become glycerol 3-phosphate. Then after this phosphorylation, so first step is phosphorylation kasi nga nag-transfer ng phosphate from ATP to the glycerol. The second step now is a oxidation reaction kasi gagamit na naman tayo ng NAD. So, ang site ng reaction naman for the second reaction is the second carbon atom in the middle. Okay, so that carbon atom bearing the hydroxyl group will undergo redox reaction wherein it uses glycerol 3-phosphate dehydrogenase and the intermediate NAD plus. So, marireduce siya sa NADH plus H, and that carbon atom bearing the hydroxyl group will then become carbonyl. So, magiging C double bond O siya. And from that, ayan na ang ating dihydroxyacetone phosphate. Okay, so from being a glycerol, magiging dihydroxyacetone phosphate siya. So, yun nga sabi kanina, the first step is phosphorylation, and then in the second step naman, the secondary alcohol, or in this one, is oxidized into a ketone. Okay? So, from being a alcohol, naging ketone daw siya. Now, for this dihydroxyacetone phosphate, so which is intermediate of glycolysis and gluconeogenesis, so andun din siya sa gluconeogenesis, can be converted into a pyruvate. And of course, we know that one of the phase of pyruvate is acetyl-CoA. And then, of course, from that, magiging carbon dioxide, or it can also be used to form glucose via gluconeogenesis. So, marami siyang pwedeng puntahan na pathway. Okay? So, take note that triacylglycerol triacylglycerol reserves would enable the average person to survive starvation for about 30 days, given sufficient water. Okay. Glycogen reserves, which are the stored glucose, would be depleted within 1 day. So, ang gagamitin para makasurvive, yung mga nagfa-fast dyan, would be the triacylglycerol reserves in the adipocyte cells. Okay? Adipose tissues. Okay? Now, kung kanina, alam natin, so, kasi dalawa yung product ng digestion, no? Glycerol and the fatty acid. So, alam na natin that glycerol will then become a hydroxyphosphate, which could either enter glycolysis or glycogenesis, or what do- uh, uh, gluconeogenesis. Okay, so from here, ano nang mangyayari kay fatty acids naman? Ano nang mangyayari sa kanya? So, there are three parts by which fatty acids are broken down. Kasi remember that fatty acids are either small, medium, or long chain fatty acids, no? Paano siya papasok sa Krebs cycle kung masyadong mahaba yung carbon atoms niya? So, meron tayong three parts here para maging acetyl-CoA lang siya. Okay? So, we have here, first step, the fatty acid must be activated, bonding to a coenzyme A. So we have here the fatty acid, we have here the A. So alam natin that the thiol group is the site of reaction. So mabibreak dyan. And that would be, so mabibreak din naman dito yung fatty acid. So the CoA and the acyl rather, not acetyl. Pag sinabi nating acetyl, CoA, doon sa Krebs cycle, dalawang carbon atom lang. Pero pagdating dito kay fatty acid oxidation, acyl-CoA ang involved. Ibig sabihin, acyl will have the carbonyl carbon and R. Yung R are series of carbon atoms. So medyo mahaba, it's either long or small chain fatty acids. Okay? So for this activation, we need the use of ATP at magiging AMP. AMP is adenosine monophosphate. Okay? And during this, meron tayong two inorganic phosphate na ma-produce from that ATP, and the enzyme is acyl-CoA synthase. Okay? So, the first activation lang, nag-join lang si CoA and free fatty acid to produce the acyl-CoA. From there, excuse me, the second step will then be the fatty acid must be transported into the mitochondrial matrix by shuttle mechanism. So, shuttle mechanism, so sabi dito, acyl-CoA is too large kasi nga acyl has a R, series of carbon atom, too large to pass through the inner mitochondrial membrane to the mitochondrial matrix, wherein the enzyme needed for fatty acid oxidation are located. Excuse me. So, a shuttle mechanism is involving the molecular carnitine affects the entry of acyl-CoA into the matrix. So, during the shuttle mechanism, si acyl-CoA, sasama siya kay carnitine, and with that, kapag naka-attach na siya kay carnitine, pwede na siyang pumasok dun sa membrane. So, sabi niya, the acyl is transferred to the carnitine molecule, which carries the membrane. So, the carnitine molecule will carry the very large acyl-CoA acyl group, and then from there, ita-transfer niya naman niya. So, pag nakapass through na siya ng membrane, iiwan na niya si acyl back kay CoA. So, parang, yun nga, shuttle mechanism. Kasi hindi nga makakapasok si acyl-CoA. So, naghiwalay muna si acyl-CoA. So, maging acyl muna siya, tapos CoA. Tapos si acyl, attach siya kay carnitine. Then, carnitine can actually transport the acyl, at kapag nakapass through na siya ng membrane, magbabalikan na si CoA tsaka si acyl. Kaya magkakaroon na ng acyl-CoA. And from there, the last step, now that fatty acid, the acyl-CoA has now, they reach na the site of reaction. So, magkakaroon na ng fatty acid repeated cycle of repeatedly oxidized. So, ang tawag natin dyan ay beta oxidation pathway. These are series of 4 reactions. So, sa bawat reaction, may 4 steps. Okay? So, sa bawat pag-oxidize niya, may 4 steps siya repeatedly to produce acetyl-CoA, FADH2 or FADH2 and NADH. So, if that series of carbon atom are and the acyl-CoA, so meron tayong CoA dyan, mag-undergo siya ng beta oxidation at involves 4 step hanggang sa lumiit ang ating acyl at maging acetyl. Okay, so yun lang yung last step, that is the beta oxidation. Of course, during this beta oxidation, may mga redox intermediates tayo dito, metabolic intermediates na NADH and FADH2, which alam natin that this could enter Krebs cycle for the production of ATP. Okay? Sorry. Which could enter, not the Krebs cycle, which could enter electron transport chain and oxidative phosphorylation for the production of ATP. Sorry for that. Okay, so in the mitochondrial matrix, so a sequence of 4 reactions repeatedly cleaves, so break niya, in, para ma-produce yung 2 carbon atom units until the carboxyl end of a acyl molecule. Okay, so this repetitive 4 reactions sequence is called beta oxidation pathway. Okay? Sorry. Okay. So going back, ano ba yung repeated 4 reactions na yan? Sinasabi, repeated 4 reactions. We have here the beta oxidation will have here the 4 repeated reaction wherein from being an alkane, kasi nga 'di ba yung ating fatty acids ay series of carbon atom, and then we have here the CO. Okay, so that alkene will then become an alkene. So from single bond here, magiging double bond because of the oxidation or the dehydrogenation reaction. From being an alkene, double bond magiging secondary alcohol, magkakaroon ng hydroxyl group because of the hydration. Hydration is the addition of water, H2O. So yung OH na functional group ng alcohol dyan kukunin sa water. And then the third reaction is the oxidation dehydrogenation again para maging yung OH naman ay maging ketone. Okay? And from that ketone, dun pa lang magkakaroon ng chain cleavaging. So, matatanggal yung acetyl part dun sa acyl. Remember, acetyl has 2 carbon atoms, while as acyl has maraming carbon atoms. Okay? Long chain of carbon atoms. So, ang pinaka goal na beta oxidation is for the production or cleavaging of the acetyl from the acyl. Okay? So, sabi dito, the number of acetyl molecules produced in the beta oxidation is equal to the half of the number of carbon atoms in the fatty acid. So, kapag meron tayong 18 carbon atoms, of course, 18 carbon atoms na acyl, kasi haba niyan, no? Ang kailangan natin ay acetyl, which is 2 carbon atoms lang. Of course, ang maproproduce dyan ay 9, half of the 18. So, 9 acetyl-CoA ang maproproduce during beta oxidation from that 18 carbon atom acyl. Kasi nga tagdadalawa nga. Okay, so yun yung sinasabi niyang half daw yung count. Okay? And then, yung number of repetitions naman daw, the number of repetitions of beta oxidation that are needed to produce the acyl is always 1 less than the number of acyl. So, ilan bang cycle? Ilang cycle ang kapag meron tayong C18, makakaproduce tayo ng 9 acetyl. Tama? Pero, ilang beta oxidation yan? Ilang beta oxidation, sorry, ano bang tawag doon? Ilang ulit na mag-undergo ng acetyl-CoA. So, kasi, ang sabi dito, 1 less. So, kapag may 9 tayo mapoproduce, mag-undergo lang yan ng 8 beta oxidation. Kasi ang mangyayari dyan, kung una, di ba 18 siya? 18. So, dun sa pangalawa, magiging 16 na lang siya plus yung acetyl. Pero yung susunod, so 14 plus, ayan na, plus another acetyl. Okay, so repetitive yan hanggang sa, kunyari, umabot na tayo ng 6. plus the C2, C4 rather. Kapag C4 na yung ating acyl, of course, mapoproduce na niya yung C2. Dalawang C2 na. Okay, so, let's just demonstrate it dito. Okay, so we have here the beta oxidation which is 18-0. Ibig sabihin saturated fatty acid yan, walang double bond. And name is stearic acid. So initially, that's the first step, dehydrogenation. So we use the intermediate FAD and mapoproduce ng FADH, which alam natin that if this is FADH could go to the Krebs cycle, to the electron transport chain para maging ATP. Now, so this one is C14, that's 14 plus 1, so that's 15, 16, 17, and 18. So that is the acyl. Okay? Ito yung acyl part. Sorry. Ito yung acyl part. Ano ba? Okay. This is the acyl part. So the site of reaction is the alpha and beta. Remember in your organic chemistry, alpha and beta, alpha is the second carbon atom and beta is the third carbon atom. Hindi natin nilalagyan ng Greek locant ang ating carbonyl kasi hindi naman siya naglalagay ng, hindi siya makaka-accommodate ng substituent. Nevertheless, the alpha and beta carbon atom are the site of reaction. So here, so hindi muna natin pakikialaman yung remaining 15, tsaka itong isa dito, so that is 16 na, no? So itong dalawa lang muna to kasi 18 yung total nila. So mangyayari dyan, so from being an alkane, sabi natin kanina dun sa step 1, magiging alkene, ito magiging double bond after dehydrogenation. And then after hydration, that double bond or alkene will then become an alcohol because of the addition of water. Okay? So from that alcohol, ayan na, kakaroon na tayo ng cleavaging. And during the cleavaging or chain cleavage, gagamit tayo ng acetyl-CoA. Kasi nga, ang beta oxidation dito sa beta and alpha, dyan sila mag-break. So mag-break dito, maiiwan na lang. So kung makikita nyo, kung nag-break sila dyan, ito na si acetyl-CoA. Ito yan. Yan si acetyl-CoA. Naiwan si acyl-CoA. But this time, the acyl-CoA, hindi na siya 18 originally. Kasi nagbawas tayo kaninang 2, kaya ito magiging 16 na lang siya. Okay? So, repetitive cycle yan. So, that's the first run ng beta oxidation. No? So, the first run, this is the first. After the second run, so ganun pa rin ulit, magkakaroon na meron tayong saturated, magiging alkene, magiging alcohol, tapos magiging ketone, tapos magkakaroon ng cleavaging. From that C14 na yan, so minus 2, okay? Sorry, ito yung first run, okay? So after the second run, magiging C12 plus acyl-CoA. So, ito sabi, each loop is the step 4. Yan yung step 4 natin, yung single bond muna siya, tapos maging double bond, tapos maging hydroxyl, tapos maging carbonyl, ketone. Okay? So, if this is the first run, so from C18, ito yung C18 natin. Okay, so kanina C18, no? Okay, so magiging, ito yung first run. Okay, C16 plus 2. Ayan. So, the second run will then become, so from C16, magiging C14 na siya. So, this is the second. And then, the third would be C12. And then, magiging C10 plus 2. Then, C18 plus the acetyl. Then, C6. C8 pala. Then, C6 is the acetyl again. And then, the C4. This is the, so 1, 2, 3, 4, 5, 6, 7. This is the seventh. The seventh run of a repetition of beta oxidation. Pagdating sa 7, hanggang 8 lang actually. Kasi nga, dalawa na yung acetyl dito na maproproduce. Kaya yung sinasabi kanina na kung paano mo malaman kung gaano kadaming repetition ng beta oxidation, laging -1 lang dun sa na-produce na acetyl-CoA. Kasi yung acetyl-CoA dun sa last, dalawa na sila. Okay? So, ulitin natin, if that is a fatty acid with 18 carbon atoms, makakaproduce lang siya ng 9 acetyl-CoA kasi ang acetyl ay 9 acetyl. Tapos, ang 8 repetitions lang. 8 repetitions, sorry. Okay, 8 repetitions ng beta oxidation. Ulitin ko, bakit 8 at hindi 9? Kasi nga dito sa ating last stage, dalawa na ang ating mapoproduce na acetyl-CoA rather. Okay? So, kapag pinag-usapan naman natin ay 20 carbon atoms, so alam natin dapat na, so divide by 2 lang, 10 ang ating acetyl-CoA, tapos -1, 9 repetitions lang. So, ganun lang yung math computations niya. Okay? Now, for the ATP production ng ating fatty acids, so na-discuss natin yan kanina and na-discuss natin to sa ibang video pero ulitin na lang din natin. So, for ATP from the fatty acids, so nakadepende yan sa identity ng fatty acids, no? Kung 18 yan, so parang kanina nakita natin. So, ano ba yung summary dito? Sa isang run, nakaka-produce tayo ng isang NAD. Isa lang. Okay? So, if that is 8 runs, syempre, okay, 8 runs, so magkakaroon tayo ng 8. 8 NAD and 8 FADH. Okay, ulitin nga natin. Saan yung, ito, sorry. Meron tayong isang FADH at isang NAD. FADH2 and NADH. So, kapag 8 ang runs natin, 8 din yung FADH and 8 din yung NADH. So, ang multiplier natin dito ay 1.5. So, that's 12. And then, kasi nga 8 repetitive sequence, no? And then, for the NADH, ang factor natin ay 2.5. So, we have here 12 plus 22. But, remember, hindi lang NADH and FADH ang nako-compute na ang napoproduce natin during beta oxidation. Nakaproduce din tayo ng 9 acetyl-CoA. And remember, this acetyl-CoA could enter Krebs cycle. At alam natin during Krebs cycle, we are producing 10 ATP. Kaya 10 yung ating multiplier. And we have here 90. So all in all, the total is 122. That's the gross ATP for one fatty acid only. So remember, if the glycerol will have 3 fatty acids, so ang daming ATP. So kaya talagang mas marami kang maproproduce from the fatty acids, maproproduce na ATP from the fatty acids. So good source of ATP sila. Okay, pero from that gross ATP, kailangan daw nating mag-minus ng 2. Minus 2 ATP. So palagi yun, ang dahilan is because of the production of ATP production from the oxidation. Ano ba yung ating gagamit daw kasi ito. The activation consumes. Okay? Sorry. The activation during the step 1 consumes 2 high energy phosphate bonds of ATP. Kaya magma-minus 2 daw tayo. Okay? So, palagi yun. -2 from that gross. Okay? So, ito. Another example from lauric acid naman. Lauric acid has 12 carbon atoms. So, alam natin that makakaproduce siya ng 6 acetyl-CoA and 5 repetitive sequence. During that 5 repetitive sequence, makakaproduce tayo ng 5 FADH and 5 NADH with corresponding multiplier 1.5 ATP and 2.5 ATP respectively. So we have here the products. And of course, that 6-acetyl-CoA will enter Krebs cycle and the factor is 10 ATP. So ang all in all ay with minus 2 during the fatty acid activation. Kaya total ay 78 ATP. Okay? So, let's have a comparison. Tingnan nga talaga natin kung yung tama yung sinabi ko kanina na mas maraming ATP na mapoproduce sa lipids kaysa sa carbohydrates. So, tingnan natin. So, kung kanina, okay. So, in the past, alam natin that one glucose unit could have a 30 ATP. So, na-breakdown na natin from the digestion, from the glycolysis, then dun sa acetyl-CoA formation hanggang sa Krebs cycle papuntang electron transport chain. So, 30 yan. For stearic acid, ito naman yung na-discuss natin kanina dun sa ating beta oxidation at nakaproduce siya ng 20. Pero take note that glucose is only 6 carbon atoms. So, parang hindi magandang compare na glucose 30 versus 120. So, pagparehasin natin sila para same yung carbon atom nila. Kasi si stearic ay 18 carbon atoms, no? 18 carbon atoms. So, para parehas sila na 18 carbon atoms, si glucose i-multiply natin ng 3 para parehas silang 18. Nevertheless, kahit na i-multiply natin ng 3 yung ating glucose para parehas na 18 carbon atoms at para patas yung basis natin, yung comparison natin, yung 30 magiging 90 lang. Okay? So, si 1 stearic acid na 18 carbon atoms and 120. So, with this, talagang makikita natin na mas efficient ang lipids as energy storage or any energy storage dun sa ating metabolism. Kasi 90 versus 120, medyo malaki yung difference.